Yeah, thank you for joining my presentation about taking Python beyond scripting. I think everyone has kind of used Python in some way. I think this talk is based on some kind of observations where I've seen kind of people struggling with actually building a product using kind of Python programming language, and how to actually kind of ship high quality Python applications. And I actually also recently went through a project where I did this myself. So I had to kind of have the opportunity to explore kind of what's the latest and greatest within the Python ecosystem to help you to kind of build high quality applications. So that's what this talk will be about. Yeah, the agenda, I think I'll do a short introduction on me, but also kind of the background, a little more background on why I'm up here. Then we'll spend a lot of time talking about linting or static analysis and how to use that with your Python applications. And we will also kind of finish off with looking into how to package and do project management in Python. And finishing it off with a non-dramatic demo, I hope, with everything will work. So the introduction part, my name is Mirza, you've already heard about that. I've been in kind of software and hardware engineering around 15 years, and over that span of time, you kind of build up certain skill sets. So I consider myself kind of a T-shaped skill set, where I kind of have deep expertise in a certain area, which is more kind of embedded systems, from predominantly Linux, but also kind of spent a lot of time working with Internet of Things, and lately also like product architecture and kind of back-end applications as well. I'm a proud like open source contributor. Over the years I've contributed to various projects, and I hope to continue doing that. And I'm currently also the CTO of Ideate Engineering AB. And we're a company based in Gothenburg doing product development and professional services in embedded and other areas as well. Then Python. I mean, I don't think Python needs like a large introduction, but I was thinking just like we need to understand a little bit the philosophy behind Python and like how it works and why it works the way it works. And I mean, in general, like it's a big tent, meaning there's it's a very mature ecosystem around Python, and it's been around for 34 years. Probably earlier as well. I mean, I think it started in like '89. I think that we generally kind of considered around 91 that it's actually released. And it's like it's a multi-paradigm language, so you can do a different type of kind of development. You can do object-oriented applications. You can do functional code. You can do generics. So this is quite wide. It's an interpreted language, which is kind of key here, which we will talk about more later as well. Because there are like, obviously some drawbacks to that and some benefits of having an interpreted language. But it is like the philosophy behind Python is that it allows you to do the things that the best suits you, and you are the one that is like best to determine what best suits you, which it will allow you to kind of shoot yourself in the foot as well. And it can be challenging to navigate since it is like a quite mature and vast ecosystem to kind of find how do I best use this kind of what's available to me. Can be challenging when you kind of start looking into it. I mean, Python is, as you know, nowadays it's very common in like AI and data, for both data analytics, but a lot of the AI applications nowadays is also the SDKs and so on are usually like in Python. It's quite common in backend and kind of web development as well, Internet of Things, where kind of I've been using it mostly. I mean, obviously the automation and scripting part, it's very kind of convenient to write a small Python program to do a specific thing or a small thing. But that's like we want to be focusing on the kind of automation and scripting part today. more about moving away from it. And it's quite common to use in kind of infrastructure as code as well, like Kalumi and other solutions, and CDK, for example, from AWS, so you can do kind of infrastructure as code written in Python. And I guess this is also like, it's not a talk about, I'm not trying to sell either like Python or you should use Python for everything. It's more of a, like, if you're going to use Python, this is a way of doing it. So it's kind of still up to you to kind of decide if it's the tool for the job and so on. So I'm not trying to kind of force anyone or try to sell something here. But there are some kind of things that with kind of the modern languages like Go or Rust that has kind of changed a little bit, kind of brought a new mindset where kind of opinion, I mean, Python started out, I mean, flexibility is kind of the key, right? You're supposed to, you should not be hindered by kind of the language or the ecosystem around the language to do something. Where kind of the modern languages have taken a different approach where you get a very narrow path of how to do things, and it's kind of an opinionated way, which works well for most, or in certain cases. But this has kind of snuck in a little bit into the Python ecosystem. That's kind of what I've seen as well, that more and more kind of opinionated solutions or frameworks are kind of popping up in the Python ecosystem, where kind of the experience is quite similar to using kind of modern programming language like Rust, for example. And when I say beyond scripting, so I mean, it's not necessarily measured by lines of code, so it's not like if your script is bigger than 1,000 lines, then you kind of need to do certain things. So it's more about kind of turning a program into a product. I mean, programs, you've probably all written kind of, when I say program, I mean you have some kind of Python applications that probably runs on your machine. You have some hard-coded paths in it, and I mean, it's okay if it fails because you can easily fix it because it only runs kind of on your machine. But once your application, or when the need arises that you need to kind of distribute that code, you need to collaboratively develop that code, then certain challenges arise that we need to kind of take into consideration. So we can't just take our program, whatever is running on our machine, and start kind of collaboratively working on it without making any changes on how we work with it and what tools we use to work with it. And types of kind of applications that I'm considering here when I say beyond scripting, it could be like command line interface tools, it could be a Python module, it could be a system daemon that does something, it could be a microservice. Typically something that, I mean, someone is dependent on. It could be like a developer tool, it could be a service that serves other services and so on, where kind of the need of raising the bar of quality of the code and so on, and stability kind of rises if it falls into this category of usage. And one of the things that we'll be talking about today as well is it's about catching things early, right? And I think many of you already know this, kind of, if you're working with software development, in general, you want to catch things as early as possible, kind of in the workflow. So if I'm writing code, I want to be able to find bugs or while I'm working on it, right? Because, I mean, as you move along these kind of steps where you push the code to a source code management system, there's some kind of integration. And I mean, obviously, once the code is deployed, that's the hardest place to kind of troubleshoot it and finding bugs and so on. And it's the most costly, obviously, to troubleshoot kind of deployed code. So the ideal is to find as much as possible, as early as possible. I mean, that's where we kind of coming to the linting and static analysis tools that we'll be looking at to help us find things as early as possible in our kind of development workflow. There are some pitfalls or challenges when you move from beyond scripting. And it can be kind of difficult to maintain kind of readability and consistency, because if you have a program that as long as it's only you using it, then as long as it works for you, that's fine. But if you're going to work collaboratively, you need to agree on consistency, and readability is important because other people start reading your code. So there's a lot of new kind of dimensions to shipping code than just having a small program on a computer. Insufficient testing leading to reliability issues, that's probably something that can be challenging. I'm not going to talk too much about testing today because it's quite an extensive area as well, but worth mentioning. Insufficient error handling could be a challenge as well. And collaboration, I think I already mentioned this, consistent coding standards can be challenging, and there are tools that can help us do this. So that kind of brings us into the kind of the linting part of Python, and kind of what's available and what we can actually do with linting in Python and so on. And linting, that's a word, it's a commonly used in computer science, so it essentially means static code analysis to catch programming errors, bugs, stylistic errors, and suspicious constructs. Yeah. And this is quite important since Python is an interpreted language, which means you don't really have a compiler or anything. So if you write your code, the first time you would discover any errors would be running it. So static code analysis is quite important to actually catch things earlier than actually the need to run it. And there are some things that a static analysis and linting tools can do for us. It can enforce coding standards. So, there's a style guide, official Python style guide called PEP8, where it's defined how your Python applications is supposed to be structured, and different constructs and so on. So using linting tools, you can actually enforce these type of coding standards to get a uniform consistency throughout the project. It can catch syntax errors. So this is again, since Python is interpreted language. If you have a syntax error in your programming, in your Python program, you would only notice it when you run the application. But linting tools can actually help us catch this while we write the program or before we try to ship it. Conventions, so that's best practices or something. That's the same thing with code smells. So with linting tools, there are some established or anti-patterns and patterns, good patterns that the community has built up. So the linting tools can actually help us find if you are using an anti-pattern, it can flag that, and then you need to react to it and so on. And it can also the linting tools can help us catching refactoring opportunities, things we'll go into that a little bit more later, actually. But it can do things like this as well. Type validation, there's a whole section about type validation later, so we'll come back to that. But you can also do, with linting tools, you can also do security checks in our code to find obvious programming errors that could lead to security issues. For example, invoking programs to the shell or something from a Python program that's typically considered some kind of security. An unlinter could flag that you should maybe consider using something else here. And with, the existing the ecosystem in Python in regards to linters, there are different ways you can use them. Usually you can use them from the command line. So there's a standalone tool that you can run on your code, and then you get some output, and then you can react to it. But it's also possible to integrate with an IDE or a code editor. So as you write your code, you can get notifications or guidance that you have a syntax error here, or you there's something wrong and so on. Which is it can be quite convenient. And there are patent like Python IDs as well that do also this for you. But typically, but you would like to have that. Not only as part of the development environment, but also as either like a continuous integration step, for example, a bit of action that verifies or runs the same kind of linter tools that you're kind of running locally, or as pre-commit hooks in Git, for example, to make sure that before you commit code, you run certain checks on the code that is being committed to make sure it passes all the kind of the linter, enabled linters. And there are some, levels of messages that a static analysis tool can deliver. And it could be, I think I already mentioned this, like it's small. Like conventions, so it could be like a missing function or method docstring. That's like a convention error that can help you enforce consistency that like all your method functions need to have a docstring. Then you can have like refactor for all bad codes now. So that could be something like a necessary else after return, and then it can guide you to tell you that you have like a refactor opportunity here to make the code a little bit more clean. So warnings, and this is kind of things like it could be a security or, but there are certain like anti-patterns that it can detect. For example, in this example, it's the subclasses one. Which has a default value for check, but it's kind of considered a good practice to actually set be explicit in what you want to happen when you get like an error code when running a subclasses. So you can get a warning from that. And the most like the error warning is usually something that's there's something wrong with your Python syntax, or there's something very wrong. That you need to, this program will probably not run if you try to run it, for example, if you have a error type of linter. So, and then you kind of get into this, okay, but what type of kind of linters or tools are available to us? And it kind of becomes a little bit complicated. I think again, the community is quite mature. There's a lot of things. There's probably hundreds of different tools that you can enable or integrate into your project, and it can become quite overwhelming. And it's kind of hard to decide, okay, what should I include or what should I not? So there's things like there's black, which is a code formatter. There's isort, which sorts imports, and bandit, which does you can do like security checks in your code. And warns that they're using kind of obvious security anti-patterns and so on. Autoflake, which removes unused code or variables, and so on. So there's there's hundreds of them, which can be kind of challenging. And there are like some aggregators, so that's kind of like opinionated solutions who aggregate maybe the most popular Python linters into one package, which you can integrate. But there are some, for example, there's one called Flake 8, which essentially, it's in the basic form, it's just a style checker. So it enforces this pet8 style guide on your code, but it has a very kind of it has a plugin system, Flake, and it has a very vast plugin ecosystem. So essentially, like all the linters that exist in the Python ecosystem also exist as a Flake 8 plugin, and then you can curate your own kind of list of Flake 8 plugins and enable them to build something that has a full coverage or the coverage that you would like. But again, it's hundreds of Flake 8 plugins, and it can be challenging. Should you enable them all? Should you or do you build it over time? So it can be challenging to enable this. And to just kind of mention or like look at it more like a selected few. And these are more like top level, or as I said, as I mentioned, they're kind of more of aggregators. There's one that's like commonly used within the Python pilot, which does style checks, logic errors, and complexity errors as well. It's very capable of, and it does some type checking as well. But one of the things with Pylint is that it's notoriously slow. So it can, if you have a large code base, it can take minutes to run on your code base. But it's very thorough, so it will find things no other linter will find. Then we have Flake 8, as I mentioned. I mean, Flake 8 on its own, it's not like a complete, necessarily a complete solution. But with the plugin system, you can kind of build up quite a comprehensive linter, so to say. And there are some new kids on the block, Rough, which is has popped up in the later years, which is, I mean, the things that it does is that, I mean, it's extremely fast. So compared to Pylint or something, it's like 1,000 times faster. Mostly because Rough is written in Rust, so they're not but one of the things that Rough does is that it has around, I think, 800 rules implemented. So it has taken kind of the most popular from Flake, for example, from Pylint, from different and re-implemented them inside Rough, and they are enabled by default. So one of the kind of benefits of Rough is that you don't really need to. The defaults are pretty they are same and pretty good. So you get something out of the box without much effort from your side to decide okay, which ones. It's a very good starting point. But Rough is also, I mean, it has some capabilities to do auto fix. So some rules it can actually fix for you as well if it detects it, which is pretty cool. And then there's more like this remake Python style guide. It's a very kind of strict, opinionated code style type of linter. It's built on top of Flake 8, so it's essentially a Flake 8 plugin. But it enables a lot more kind of checks that are very kind of strict, which is quite similar to, for example, if you're working with Rust or something like that. It becomes a very kind of, it creates a very narrow path how you're supposed to write your Python code. Could be for some, but not for everyone. And I think one of the things is that, I mean, these are not necessarily mutually exclusive. So you can use more of them in your project. And I mean, it's not uncommon to use Pylint together, for example, either with Flake 8 or together with Rough, because there is some overlap, but they do also complement each other. So, I mean, it's not necessarily a bad thing you don't really need to pick, you can actually have more of them. And since Rough is I mean, so extremely fast, the overhead of actually enabling it together with something else is quite slow. And it might catch things that the other ones do not. So with these type of kind of linting tools, we are able to kind of cover most of the kind of things that we covered before. We can enforce coding standards, we can make sure syntax checks are in place, conventions and so on. But one thing that the previous linters that I mentioned, they don't do type validation that much. So I think that's what I want to get into, because there's a dedicated kind of ecosystem around type annotation and type validation in Python, which we need to get into and look at how we can use that. So Python typing, I mean, Python is a dynamically typed language by default. So this means that, I mean, it still has types, but the types are resolved during runtime. So if you have an int and a string and so on, I mean, it still has types, but they are first resolved when you run the application, which can be kind of, so if you have some kind of typing problem, you will not notice it until you hit that code path with certain kind of inputs and so on. And in around 2014, Python introduced something they call like gradual type system, which is an opt-in essentially to enable statically typed style programming in Python. And a lot of things has happened since it was introduced in 2014, and it's quite mature nowadays. And there's like several projects that help you enforce or build Python applications about statically typed as well. But I think one of the key things to mention here is that it's a gradually typed size system. So it means that you decide since this, going back to this Python philosophy of having this flexibility, the typing system is completely opt-in, and it can be you can have one method that's typed or type annotated, and another method that's not type annotated, and that's completely fine. And when you run, for example, a type checker, they will usually just verify the methods that are type annotated. So you can still mix. And maybe a certain part of your code is very important to have statically typed, but other parts it's not that important, and that's okay. And to have a look a little bit at type annotations. So that, this essentially means that you can say this variable is an int, or this variable is a float, and this. If you're using a statically typed language like C or C++, this would you don't really have an option. You have to define what types your variables are. But this essentially, you can do that in Python as well. For example, to annotate the variables, but also for example, to annotate methods or functions, where you can say the input in this case is an int, and then the return value is a string. And the key thing here is also the Python runtime doesn't do anything with type annotations. So it's the only way to actually use type annotations is using a static analysis tool that will check your type annotations and compare them to your actual code to see if you've implemented. But it has no impact on the actual runtime. So even if you have type errors, and as long as they programmatically somehow resolve, the Python application might still run. So it is, but it is primarily enforced through static analysis. And this is an example of what it can look like if you do it what a static analysis tool can do for you. For example, in this case, we have the input to the method is an int, but here I'm trying to call the method with a string instead, and then the static analysis tool is telling me that there's an error here. Otherwise, if you don't have this, you might have, then you would notice this problem during runtime instead. So that's the key thing. And why type Python? Why type annotate? Maybe it's obvious, maybe it's not. But I mentioned it has no runtime impact on the actual program, which is so it will not make your program slower, and there's no real runtime checks of it at all. But obviously, one obvious thing is that it helps with communicating intent. So, if you have type annotated your method or your class and so on, it's quite clear what you intended, what the input should be to this function and so on. So if someone else is calling your code or working with your code, it helps with ability. But it also, typing is also to catch typing problems. So if you have an input that should be an int, but it is a string, you want to catch it early and not during runtime when your code path is executed. But one strength of Python typing is you can integrate it. It has very good integrations with integrated development environments and code editors. So it helps your code editor to know what inputs when you write your code, it can help your code editor to determine what inputs are required for this method, and it can help you validate as you write your code, are you doing it right or wrong. And again, here, I mean, there's a lot of tools and ways of doing it, which is the Python way, so to say. So there are a couple of, I mean, these are the four primary type checkers within the Python ecosystem. MyPy, which is kind of the original and is the reference implementation of actually statically type checking Python applications. Developed primarily by the Python community with some backing from Dropbox. Language is Python, and it's sort of like one of the more popular ones, so to say, when you look at GitHub stars, if that says. It's not the only metric, but it says something about like how long the project has been around and kind of the scope. And then we have Pywrite, which is a tool from Microsoft. Same, I mean, it does type checking on annotated code. Pywrite is the only one, I mean, there is a official specification of the Python type system, and Pywrite is the only one that implements the full specification. So if you want something that's really complete, Pywrite is probably the right tool. And some of these tools as well can do inference as well. So they can do type validation even if you don't have type annotations. You can kind of figure out your intent and warn you if you are using it wrong. So that's something I think Pywrite and PyType can do. Even if your code is annotated, it can actually help you to figure out or find typing problems where you're kind of passing around different data structures. And yeah, I mean, and it seems that all the big ones have a Python type checker. I don't know why they all have different ones, but I guess there are reasons for this. So there is one Pyre from Meta, and then PyType from Google. More or less, they do the same things slightly differently with some variations. Usually, MyPy is probably like the slowest, and then the other ones are more high performant, and things like this. So. But in the end, I mean, there are tools to help you kind of check your code, make sure that you're kind of typing is correct. And looking at kind of this, I think we talked a little bit about the pitfalls moving beyond scripting. We looked at some of these tools that we mentioned can help us kind of maintain readability and consistency, improve our error handling, increase complexity, or it can help us out. But I think one thing that I haven't talked about yet is the collaboration challenges and inconsistent coding standards. And this is like pretty straightforward. I think in just use a code formatter, I think is my recommendation. Because there is like a coding standard, which is at that 8 in Python. And there are like code formatters implemented based on that. There's both black and then there's rough, which also implements this. So it essentially kind of eliminates the need of to think about how my code is formatted and so on. Just run rough format and it fixes it for you. And then you can do rough check to make sure that you're compliant with the coding kind of format. So that's kind of like a given almost to avoid discussions about how to format code. And this is also the way that like Rust or Go, you don't really have an option how to format your code. They come with a built-in formatters, essentially. There's only one way to format your code and just go with it. And one of the the last things is the increased complexity in dependency management or project management. When moving kind of beyond scripting, you might have dependencies on other Python modules. You have like a project structure, and this can be kind of challenging And the traditional way was, I mean, there's this Python virtual environment where you can set up, for example, a requirements.txt file that says, okay, these are the Python modules that my application is dependent on, and then someone else, if they are setting up a development environment, they can set up their own virtual environment, Python virtual environment, and then run pip install on the requirements.txt file, and then they will get there. But it has, I mean, there's a lot of, I think this is quite basic. And it works, and it can work for some use cases. But typically you want more, because I mean you want a project structure, you want to be able to build packages out of your Python, you want to be able to have like stronger lock mechanisms to ensure that like whatever you specified in your, for example, requirements of the .txt. Because once you run pip install, for example, requirements.txt, and if someone makes a change in the virtual environment, that will not be detected. Things like this. So it's quite easy to kind of break the development environment. So you would like stronger like log files, for example, which have strong hashing and so on to ensure that your kind of development environment, or when working with this Python package, you have the exact kind of modules that you need that will work, that have been tested and so on. So that's where kind of these more advanced project management tools like Poetry and UV come in, and where they kind of fill in these gaps. And I think Poetry has been around and been quite popular for a long while now, while UV is kind of a new kid on the block, and has kind of removed a lot of the pains of doing project management, I think, in how you do it in Python. And I think that the next step is for me actually to show some things using UV on how we actually apply all of this that I've been talking about and how we do that. So let me see if I can kill this. Okay. Let's make it bigger. Okay. Let's see. Okay. Then we can start here. And I think one of the benefits of like with these, so I have UV installed. I hope you can see this. Is it okay? Yeah. I have UV installed. So some way you need to install this in your environment, for example, through pip or some other, depending on your Linux distribution. So one thing that UV helps with is that you can actually use it to can help you kind of get started with the project structure. So if we say UV init package, and the package will create certain things. You can also say like I'm building a library and so on that will populate depending on that. So if we do the init package, we build the package. Okay, look for this. So then it creates kind of a very project structure. And then you can use like UV run foss-north. It actually runs our code or module. And I mean, if you look at the code, it's just a printout. So we can use the UV to run our module as well. So I think we can add this. We can do like it in. See that? So let's say we want to add rough to do like static code analysis, but also do code formatting of our code. So that would be, quite easy now. So we can use UV. We can say add. And then we say for the development environment, because we don't want to add this as like a package dependency that gets installed, but we only want this as a development environment. So we want two things: we want pre-commit and we want rough. And pre-commit will help us run it as like a commit hook, and rough we also need to actually run the application. So when you run this, and you can see that it modified. There's this project file. So it has updated that the dependency group, and it has added like the pre-commit and rough packages there. And then there is also a log file, which is like a strongly hashed, so that we get like, if someone else would use this, they would get the exact versions if you are running it as well. And so to add, we need to, I just need to copy something. This is a bit harder to type. So we need to create like a pre-commit configuration where we add the rough linter and formatter, and we do it like that. And then we can say we can add all of this, and then we can run pre-commit install, which kind of installs the pre-commit hook, and then we can also run it. Pre-commit. Yeah, you can see like it passes. We don't have any like syntax errors or whatever. The code formatting is a bit, but what is very small at the moment, so we can commit that. And it's kind of, I mean, we can repeat this now as well for example, to add something. Where is it? Okay. So we can continue. So let's add like a static type checker as well. So then we can run highlight. Again. So then we have pyrite installed. But then we have the pre-commit hook as well, again. And then we run pre-commit install, pre-commit run. Then we have a static type check as well. Oh, good. So let's commit that. So it's quite easy, I mean, to add this. I mean, and this was quite, without using like something like UV or poetry, these type of things can be quite challenging. Or it can take, there's some churn to actually add it to a project and so. So nowadays I think it's quite simple. So I want to do one more thing. So we want to add pilot as well. I think it's. And this will actually see, let's add it. We need to add pilot, which is the linter. And then we need to add a pre-commit hook as well. And then we can run pre-commit install again. And we can run this. And then we can start to see that actually pilot. And one of the things with pilot, like the defaults of pilot, is it's quite like strict. So it's going to fail. For example, it actually found 2 errors now. So it says that my module doesn't have a doc string, and then I have a method that doesn't have a mock doc string. So I can't. So this is kind of, this will prevent me from committing. So if I want to. But yeah, I mean, the idea with pre-commit it will run when I try to commit code, and right now it won't allow me to commit this because we have some issues. So we can actually fix those issues. So I mean, it just wants me to add a doc string. So module, doc string, and then maybe the method doc string as well. I mean, this helps kind of enforce consistency. So, I mean, if that's a rule that in your project all your methods needs to have a doc string, then Pylon will kind of help you enforce this. we'll on this. Then there is like a format error, but rough can fix format errors for us as well. So, and then if we run this again, then we should be fine. Yeah. And then it will allow me to commit this variant. Yeah, I think that's what I wanted to show. This logic. Never mind. Because that's the end of it. So yeah, that's what I had, and I'm happy to take some questions. We have like 10 more minutes for the session, so if there are any questions, I'll happily answer. Do you have a microphone or something? There's a raised hand. Yeah, here it is.
Thank you for the good presentation. I can use this U-beam, but I was wondering, like, what is the maturity of this project? That do you actually now recommend it over poetry, or what issues can be found with this new kit in the book?
I mean, it's been around for a while now, so I don't think it's not that new. It's been growing quite, the popularity of it has been quite rapid growth, because it does kind of bring in, it's quite like the simplicity of it has kind of brought in. I mean, the team that is behind UV, I mean, it's this company called Astro, and they also kind of built this rough linter and formatter. I think Astro is kind of working on creating something that's very, I think, Rust inspired. I think that's what they're trying to get at, so that you get the same experience when you're working, for example, with Rust, you can actually replicate it in Python. So I think a lot of the UV commands and so on is from Rust as well, or from the cargo application. But I don't know if, I mean, it's up to, again, I can't really make any recommendations up here. I'm quite fond of UV, and I think it is very simple. There's power in that simplicity.
When you consider static analysis tooling, you listed Bandit as well, is there a way to enforce a transitive, to perform this static analysis transitively over all your dependencies to ensure everything you depend on also doesn't include any of the issues that will be highlighted by the linter? Because a lot of the linter tooling usually only works on your code that you are working with directly, but it doesn't take into account your transitive dependencies. And with respect to things that are happening there, if there's a security issue, that might be a transitive dependency, but your linter doesn't tell you.
No, yes, so exactly. So all of the ones that I mentioned here today is they only work on your code, so it doesn't kind of inspect the dependency. But some of it works with the dependencies, for example, the type checking. So if the dependency that you are using has implemented, has type annotations or provides kind of type stubs, then the type checker can verify that you are using you're providing the correct inputs, for example. But yeah, the other static linters, I don't really know of a transitive way of doing that. It's mostly each project, I guess, they have their own they use the same linters probably to verify their code and so on.
Super, any more questions? If not, Thank you very much, Mirza.
Thank you very much.